Go.
Okay, so today what we're going to talk about is the fermentation lab. And so I'm going to show you what you need to do to set up so that you can run this laboratory. So the first thing I'd like to show you is right over here, if the camera can take a look. This is the Veneer Lager Pro box. You might have used this in the past with some of your other experiments, or this may be the first time. And you can see here, this is where it plugs into the power. So you just have a power cord that plugs into the wall. And then notice here you have channels, channel 1, 2, 3, etc. And you're going to want to plug your probe, which in this case is your CO2 probe, right into one of these channels. I've chosen channel 1. Then your box plugs in here, ultimately to the USB on your computer. Okay? And when you push the button, you should hear a little noise, and hopefully you can hear that. It's like doot doot doot, and that lets you know that indeed what you have is working. And so now what we're going to do is move over here to the computer so that you can actually see the computer screen. And what we're going to choose on here is the icon right here of Lager Light. And so we're going to choose that icon, and in a moment it's going to open up. Now what we want to do is really choose our probe. So we're going to choose experiment, okay? And after we choose experiment, we're going to choose set up sensors, show all interface, and then that's going to show us the little box. And we can go to channel 1, and it will allow us to choose the CO2 gas probe. And when you're doing this, it's written in your lab book, and you'll also be able to see this more closely. After you've chosen that, you go ahead and click out, okay? And now your probe is ready to go. You can see right here this little green collect button. When you're ready to make your measurements, you're going to hit collect. And when you hit collect, it's going to start producing a graph for you. Okay, so now we're ready to actually set up the rest of the experiment. So let's move around to the hot water bath. Okay, so what we have here is the hot water bath. Now, there's some special things you need to know about the hot water bath. If the hot water bath is all the way empty, you have to unplug it so that there's absolutely no power, plug it back in, and then add water to it until it stops beeping. If you try to do it the other way around, it won't work. If the water bath has been unplugged and there's water in it, you have to empty it and dry it and then start over. You can't just plug it in. It will continually beep. So you can see here that our water bath is set to 42 degrees centigrade. We're going to actually, for this experiment, want it to be down to 37, which we can control with this button. And I'm just going to set it down here to 37 degrees because that's what we want. Okay. Now, we're ready to add our water and our yeast, because remember, with fermentation, yeast is actually going to break down sugar and ultimately produce what is lactic acid, or in this case we're going to reduce acetaldehyde and produce ethanol, right? And a byproduct is going to be CO2. And that is because with pyruvate we break off one of those carbons, remember, and that carbon comes off as a CO2. That's what causes bread to rise, those bubbles of CO2. That's why we put yeast into bread. And here we're going to see this happening, and we're going to be able to measure the rate of fermentation. Now, in each bottle, each time that you set this up, you're going to be adding water, you're going to be adding yeast, and then you're either going to be adding sugar or honey or syrup or equal. And we'll be able to see how efficient the yeast and the enzymes that are in the yeast that undergo fermentation, how efficiently they work. So the question, the experiment is, which substrate can yeast utilize most efficiently? Okay, is it equal? Is it sugar? You would expect it to be sugar, but you might be surprised as to which one it is. And of course, you will have to hypothesize of the choices your instructor gives you, which of these will yeast be able to use most efficiently. So what we're going to do here is we're going to add some water. Now, your lab book is going to tell you specifically how much to add, and you need to follow that. In this case, I'm just going to add a little bit of water I'm not going to worry about measuring it, but you will need to. Okay, and then I'm going to take my scopula here, and here's the scopula, and I'm going to just add a scoop of yeast. Generally speaking, it's going to tell you exactly how much yeast to add, but about 2 scoops really is pretty good. So we're going to add that dry yeast, mix it around in the water so that it is into the water, put in our probe. Now here's something very important. Your probe cannot be in the water. This probe measures gas. And if the probe gets wet, it won't efficiently work. And now we take the entire bottle, make sure that your lead ring, which is this blue ring, is on your bottle, and set it into the hot water bath. Of course, the warm water is going to cause the enzymes in the yeast to work more efficiently. The heat is acting as a catalyst to speeding up the rate. And now we ultimately could, on our computer, have our colleague hit collect, and it will begin graphing the amount of CO2 that's produced. If the fermentation is occurring more optimally with sugar, then let's say equal, what will we expect from the curve? We would expect the curve to be sharper, in other words, to increase faster in the case of optimal function. It will increase slower or have a lower or flatter slope in the case of a less optimal condition. So that's what you need to know to set up this laboratory, and in another video we'll show you some of the results that you can find. And with that, I thank you very much, and I hope you have a wonderful day.